Hello there, welcome back to the channel. In this video, we are going to see how to set up a MicroK8s cluster in the Ubuntu server. MicroK8s is called hassle-free Kubernetes. Is it really hassle-free? Let's find out. So if you don't know what MicroK8 is, then here is the simple introduction. It is a Kubernetes distribution and it's zero ops, pure upstream. That means it is a clone of the original Kubernetes, and then they added a few helper methods to keep things simple so that anybody can manage it. The main goal for making this is to help it run in developer workstations locally for development purposes, and also deploy it in production. Practically runs on almost all the environments. It runs on ARM, it runs on Intel x86 architecture, it runs on Raspberry Pis and IoT devices. It also has a lot of batteries included. That means it comes with a lot of add-ons and a very sensible defaults, so you don't have to worry too much about how you set it up. So it comes pre-configured, and yeah, it's also Kubernetes certified, and it's very minimal. Updating Kubernetes is also pretty easy when you're using MicroK8s. You can update your Kubernetes cluster in a few commands. Yeah, so that is a very simple introduction. It's actually made by the guys in Canonical. They are the ones who made Ubuntu, and it has a really good support with Ubuntu. So we are going to use Ubuntu server with MicroK8. And why use MicroK8? So the main reason I'm actually considering using Kubernetes at all is because the future of Docker Swarm is very uncertain. You have no idea what's happening with Docker as a company, and then they sold the enterprise division. There is no features coming in. They're barely maintaining it. So staying in Docker Swarm doesn't seem like a good idea, but going to Kubernetes for just personal use also sounds like nuts. So I was looking for a compromise, and then searching for a good alternative for Docker Swarm, and then I think MicroK8s is the best option for Docker Swarm replacement. So I tried it out, and then I liked it. So I'm making this series on how to deploy a simple single node MicroK8s instance and then do a normal developer things, which I do. Yeah, so that is the why. And what are the goals for the series? So the goal is to first set up the MicroK8s in an Ubuntu server, and then add a bunch of add-ons, and then use kubectl. So you can copy the configs. You should be able to use any kubectl and then connect to the Kubernetes cluster and do your normal operations using kubectl. And the second thing is set up a reverse proxy to redirect containers. So you have a single node Kubernetes instance here. We will use nginx, that's the ingress controller, to redirect traffic to the container. And we will also use Let's Encrypt for SSL certificates. And I also use my own registry. So we will deploy a registry, and then I want to deploy a Postgres for my application. So most of the time I use Postgres database. So we will use Postgres. And then I will use the disks the disk or the host drive for registry, and then for Postgres we can ask the Kubernetes to provision a volume for us so that you know how to use the host, and also ask for Kubernetes, hey, can you give me 5 gigs of storage for my container? And finally, most of my applications are .NET apps, so I will create a sample .NET application that connects to the database and then deploy it. Yeah, so this is my normal workflow. So I want to achieve all these goals, and then deploy it, and then see how it works out for me. And finally, what will be the cost? So the cost, what I'm looking at here is 15 euros. If it's not going to go more than that, 15 euros or $15. What I'm going to use is I'm going to use Hedge Cloud, but you don't have to. If you feel like you can spend a little bit more and then get your own VM somewhere else, get it. But I have a referral link in the description, which will provide you with 20 euros free from Hetzner. You think like, hey, I will try it out, and then if I like it, I like it. Otherwise, I just move on. Use the referral link in the description. Yeah, this is the new series for 15 euros. Create a Kubernetes cluster and then see how it goes. I have divided the series into 4 parts based on the goals. And first part 1 is to set up and then connect the Kubernetes. This is the part 1 of the MicroK8s series. In this, we will set up the Ubuntu server and then install MicroK8. And we will also connect to the MicroK8s from our kubectl. And I can also recommend Lens and a few other. So let's see how to do that. The first step is log into your Cloud or DigitalOcean or whatever the cloud provider you're using. If you don't have the cloud provider, I have a referral link for the Hetzner. It's free. Try it out. You will get 20 euros for free. Just try it out and then you can follow along. So the first step is to create the projects. It's nothing fancy, just go and click new projects and then you can create it and then add the SSH keys. I have done both. So if you come and check, I don't have anything except the SSH keys, and I also have IP address which is connected to the DNS so that it's easy to set up for myself. I will explain how to set up the IP address as well. So first, create the project. The first step is creating the firewall. So we have to open the port 2020 because that is the SSH port, and then we need port 80 because that's the HTTP port, and then another port is 443, and then the third is 16433. So this is the Kubernetes port. You can come and then see I have done this here. You will see how to add ports and things like that. Don't forget to add all the 4 ports because we need all the 4 ports, and then we can leave the outbound empty and then give the name whatever you want. So we have 4 rules and the firewall ready. So the next step is to go and create the server. Create the server. I select location Nuremberg because I have the IP there. You can select whichever location you want, and then I am going for the Ubuntu, and I'm going to buy this 4 CPU 8 gig version. I will select the firewalls, assign the existing IP. This is the IP which I have configured, and then give the name as kdev1. And then you can click create and buy, and it will just create your machine. Just wait for it to finish. It will finish within a minute or so. So the next step is you have to assign your domain to your IP. So the first thing is to create the A record and then also create a CNAME record for star so that all your requests to all your subdomain is redirected to your main domain, and which goes back to your IP. I have already done that. That's why I had the primary IP reserved, so it's easier for me to record the video. So you can come back and then verify it by saying kdev. Yeah, so as soon as you type kdev1.enterprise.com, it goes to the IP, which is 78.46.198.77, which is the IP for the machine. Okay, the next step is updating your SSH config. So I have this file called .ssh config in the root, and in that root I have mentioned the host as kdev, and then I have added my identity file as my SSH file. If you don't know how to deal with SSH, you get don't add SSH here. You will receive a email, user ID and password in your your email, just not so secure. But if you are playing around, yeah, it's not a problem. Yeah, so you can at this point your server is ready. You can directly SSH into your server. To do that, okay, I forgot to add the comment because it's pretty easy. SSH root, you click, it will ask you to add a fingerprint and then give the password if you have the password. Most people usually don't have the password. Yeah, that's it. You are inside your server. It displays some basic statistics here about the server. This is the system load and the memory usage, and you can find all the basic information when you log in. So the next step is to upgrade and update, so you can follow all the instructions here. And I also created setup script because yeah, it's easier to just copy and paste, but I will do it one by one to explain. So the first step is we are updating the machine. It's just sudo apt update. So even though we just created the machine, it's better to, it's a good practice to just update all the mirror package manager, and also upgrade in case if there is any updates available for the packages which are already installed, which we are. So just give S. The internet is very fast, and then the machine is also reasonably fast, so it will be done in like a minute or so. Okay, our update is ready. So the next step is to install snapd. So we are going to use snap to install the Kubernetes installation. So the MicroK8s is distributed as a snap package. It's just single snap package. You just say install the snap, the entire Kubernetes is packaged as one thing, and it just runs. So it's easy to install and update. And this is the version of the Kubernetes. So if you go to MicroK8s website, getting started, you will see that the channel is 1.2.5 because at the time of the recording that is the latest Kubernetes version. Yeah, so that's what we are going to do. We just use that as a snap package, and then it just downloads the MicroK8s and installs it for you. Okay, it seems like the MicroK8s is installed. Let's go to the next step. The next step is joining the group. Just copy and paste the command, and then give the proper permission to the kube file. And the next thing is sign in as the user. Perfect. We have done all those things. Now just check the MicroK8s is ready. Yes, it's running. You can see the add-ons which are enabled here. So we don't have so much enabled. The package manager is enabled, the Helm is enabled, and the Helm 3 is enabled. Everything else is disabled, which is what we need. We will enable things one by one. You can also go and then check the number of nodes, which in our case is just ours. And we can also create the alias so that we can just type kubectl instead of MicroK8s kubectl. Now, if you go and then ask for the cluster info, it says 1643. That's the port we opened in the firewall, if you remember. Okay, so now make sure you install the kubectl tool in your machine. So if you open this URL here, you will see that the kubectl is the command line tool. You don't have to log into the machine to manage the Kubernetes cluster. You can use the kubectl tool to manage the cluster. So here is the install instruction for Windows, Mac, and Linux. Click on the Windows, and you have a lot of ways where you can just download and use the kubectl. So yeah, just follow these instructions. You can use Chacos, kube. There is also winget. Yeah, follow however you want to just install the kubectl. And for the kubectl to work, you need a kubeconfig, which is available when you type MicroK8s kubeconfig. So this is the kubeconfig. Yeah, so just copy the kubeconfig and then paste it in your kubectl machine, wherever that is, and it will just work. So once that is done, let's enable all the add-ons. So I'm enabling DNS, so ingress, Prometheus, that is for the data collection. It monitors the cluster and then provides charts. And then cert-manager for the let's encrypt, postpath for the storage. Let's see, and now enter. This will enable all the add-ons. It will take a while. Let it go. Don't stop anything in the middle. It will enable all the things, set everything up, and then we can move on. Okay, all the add-ons are enabled, and we also have storage enabled, DNS enabled, ingress enabled. So everything is enabled right now. So let's go and check the namespaces first. Yeah, so you could see Prometheus, you could see kubedns, nginx. Okay, everything is running, and then there are a bunch of things which are still creating. Yeah, it should be ready soon. Yeah, okay. Most of them are running except Loki in from the observability, but it will start soon, I guess. Yeah, but yeah, let's go to the next step. Yeah, so this is a setup script I created while testing out. So this is like all the steps we did. So if you don't feel like typing it one by one, just put it as a setup.sh and then copy and paste and then run it. It just does everything for you. So as I said, you can view the config and then paste it in, and then paste it in your kubeconfig file. And there's also Lens. It's a really cool tool where you can actually you have a GUI, graphical user interface, to manage your cluster, which is pretty nice. Now let's try to install OMyZish, because I kind of like autocomplete and my command validation, things like that. So I usually install OMyZish in my shell, and for that it's a pretty easy setup. You just update a bunch of update the packages and then install the Z shell, and then in this one single command you will be able to get it. I have already done that, and then now installing the syntax highlighter plugin and also the auto suggestion plugin. Just helps you to type things easily. Just open the ZH. Okay, here this is I need a theme called Agnoster, and yeah, it's good if we update the plugin as well. Forgot to do that. Let me go back. Here's the plugin. We have a bunch of other plugins by default. And we can also add the aliases here so that we don't have to worry about it again. Okay, now just source, and then your terminal looks so much better. Yeah, so we have our terminal ready. Our kubectl command should just work fine. Yeah, so our kubectl command works, everything works, and our terminal also looks nice. This is it for the part 1. In part 2, we just see how to enable the add-on if you did. This is the part 2 of the MicroK8s series. So in the part 1, you would have set up all the stuff already. I think it's important you have the MicroK8s running with all the add-ons enabled, because we are going to use cert-manager, and cert-manager is an add-on, and if you want to know whether it's enabled or not, just check the MicroK8s status, and if it's not enabled, make sure you enable the cert-manager. So the first thing is to create a cluster issuer. So if you don't know what the cert-manager is, it is the Kubernetes certificate manager. So you can issue certificates from variety of resources. It supports HashiCorp Vault, Let's Encrypt, and few other sources. We are going to use Let's Encrypt because it's free, and but the SSL certificates is only for 3 months, but the cert-manager takes care of checking that and renewing the certificates for us. So you basically just make sure you configure the cert-manager properly, and then forget about securing your URLs, because it will automatically be secured. configured. So the first thing is to create a production issuer. The production issuer will have a kind of cluster issuer, and then make sure you change the email here, and the Let's Encrypt informations are available. So of all these files are available in the GitHub repo. So if you come here and check the repository here, I have provided all the files as a GitHub repo. So what you can do is just copy the URL, put it in the server home. Yes, can see there is a cert-manager folder. Yeah, so this is what I have for the prod.yaml. You can see the cert-manager has the version 1, the kind is cert issuer. I changed the email to my email address, and everything else is the same. So what we are going to do is we are going to apply prod. So this will create the cluster issuer, and then this will create the staging issuer. That's it. That's basically it. We just created a cluster issuer. The next is setting up the nginx. We are going to use the nginx ingress controller. Again, make sure you check the add-on is enabled. If it is enabled, we can test a HOMI application, which I have created, and then see if the HOMI application actually works. The HOMI application doesn't have anything else except the cert-manager, which is using the Let's Encrypt, which we created, and the ingress class. I would recommend go back, and then you would see the HOMI folder, and then you can see the file here, the HOMI deployment file, and you can apply it, and then you would be able to visit this URL, because that is the URL we mentioned, and it has a fake Kubernetes certificate. And if we go in, yes, now the certificate is issued. You're basically seeing the host as homi.kdev.enterprise.com, and these are coming from the Kubernetes deployment. Yeah, so that means two things. Our nginx ingress controller is working, and our cert-manager is working. This is a very simple deployment. We didn't have any storage usage. If you have just a container and it just has to run, this is pretty much it. You just create a deployment, and then this is where you specify the container information, and then create a service for that container. And in Kubernetes, that's how you expose the container. You mentioned the port as 80, and then this is the ingress route. Ingress is what exposes the service to the outside world. So in the ingress route, we are mentioning the host as homi.dev.enterprise.com, and in the TLS section, we are mentioning the TLS name and also a host. And in the annotations, we are mentioning the cert-manager cluster issuer, which is Let's Encrypt, which we created here. This is the name which we created. So it will look for this cluster issuer and then issue a SSL certificate, and then you can come and then you deploy the ingress. It will be automatically exposed. So this service connects to this service, and this port connects to this port. Yeah, I know we are actually using 3 services to expose a container, but that's how Kubernetes works. If you're coming from the Docker Compose file where you just define your service and then it just works, it's a little bit more work. If you don't know what this file is or how these things work, I would recommend you go and visit the getting started section of the Kubernetes, and then in the concept section they just explain things in a very simple way, where they explain like, okay, what is the traditional approach, what is the containerized approach, and the cluster architecture, how does it work, and then what does service mean, what does ingress mean, what does pod mean. So you can get an idea. The documentation kind of looks weird, but it is useful. You can understand most of the things. Yeah, so we are done with the part 2. In the part 3, we are going to deploy a registry, because I don't like using a private registry or paid registry. I always host my Docker containers in my own registry, and I like that registry to be protected. I don't want to expose my private containers as well. So let's see how to do that in the next video. And I want to use a Postgres database because I want to deploy a .NET application which connects to a database, and my favorite database is Postgres. So and also both of these need disk space. So for storing a registry, you need to store the files somewhere, and also for the database, you need to store the file somewhere. So you will also see like how we can request a storage, or we can use the host storage. So that's coming on. This is the part 3 of the MicroK8s series. In this, we are going to deploy a registry and deploy a Postgres database in the MicroK8s. So I have done this before in Docker. It was pretty easy. Let's find out how easy it is in Kubernetes. So the first step is the same as what we did last time. Create a password file, and the password file will contain the password. So let's go and do that. I would say I'll just go to the home directory. I will patch and then create the password. And the next is running the HTTPS Docker container. So I would run it locally in my machine. So I want to have a password with a username which is admin, and then the password would be standard. This is a very unsecure password, but for the demo purposes, it works. So this is our hashed password, and so we have to place that in this file. So let's open that up in the nano and paste it, and then save it and exit it. That's it. We stored our password in the file. Let's create a namespace called registry. So namespace is created, and then from the file which we just stored, create a secret called auth-secret, and then store the content of that file we just created in Kubernetes secrets. Okay, it's not MicroK8s, it's MicroK8s kubectl. Okay, now we have our secret created. Yeah, the command here is wrong. I will try to okay, now this is something important. So I would recommend you just open a notepad and then paste it and look at this thing very carefully. So there are too many things happening here. So first thing is kubectl create secret docker registry create. This is the name, and we are creating it in the default namespace, and the Docker server is going to be registry.kdev.antosubhash.com. This is my domain. It can be different for you. And in the username, I give admin, and in the password, I give @wrd1. So if you want to confirm the password, I give @ssw0rd1. So this thing which we created the thing with, we have to pass it here, and the email, I'm gonna give my email, bash@live.com. So what are we doing here? We are creating a Docker registry so that once the registry is created, we can use this to request the container from the registry we created. I hope I'm making sense. Yes. So you see we have two secrets. One is auth secret, which is the secret from the file registry.password, but there is this registry cred that is the secret for the registry which we are going to create. We didn't even have the registry yet, but we are just setting up all the secrets first so that it's easier going forward. Now let's create the folder, because we have to put the files somewhere when we upload the Docker images, right? So let's make a directory in the mount and let's create the deployment. So we have the folder, and yeah, this is normal Kubernetes stuff. We are saying the namespace, then we are saying, hey, I have a deployment, and the deployment has a volume, which is also there's also a cert volume, and then there's auth volume, and these are my environment variables, and these are the volumes. So for the repo volume, we are using the host path, which is /mount/registry. For the cert volume, we are using the secret, which is registry TLS secret. For the auth volume, we are using auth secret. Remember the auth secret, this secret. So, and then the normal thing which we do in Kubernetes, we create a service for the pod, and then once the pod is, when the service is ready, then we have to create the ingress route. We are setting the proxy body size as 1 GB. Because I don't think we would have containers bigger than 1 GB. So yeah, I'm just putting this here. You do whatever you want. Again, normal Kubernetes stuff, setting the host TLS, setting the rules for the host, saying the service name. Yeah, make sure you just change the URL here. This is my URLs. It might be different for you. So yeah, just use those URLs. I think I have it in my Git repository infra folder. There is a registry folder. Okay. Let me check everything is correct. Yes, we have the registry folder. We have the auth password file. Now let's apply the registry and then see what happens. Let's get the pods and then see what's going on. It says container creating. Yes, now the container is running. Let's check the service. Service is running. And finally the ingress. That's the important one. And it seems like the ingress is also running. How do you check? Let's log in. Yes, our login succeeded. So if this succeeded, you can be sure that the registry is working fine. You don't have to worry about it. Yeah, so what we have done is that we created a folder called mount registry, and then we just set up a pod to push all the incoming Docker containers into that folder. But this is not always a feasible solution, because the Kubernetes is kind of designed in a way that you don't manage the hardware. The Kubernetes manages the hardware. So when you want some storage, you let the Kubernetes know, like, hey, I want a storage, and it provides a storage. How does it do? It uses persistent volumes and then sets the storage up for you. You don't care which machine it is. It just figures it out by itself. So how do I do that? For that, you have to make sure the host path storage is enabled. Go to MicroK8s status and then enable the MicroK8s host path storage is not enabled. And then we can set up the persistent volume claim. So in this persistent volume claim, what I am saying is like, I want a persistent volume claim, which is called Postgres PVC. It has a read and write access, and the size of that claim is 5 GB. So what Kubernetes will do is it will allocate 5 GB in the disk space of the machine, and then allocate it for this pod, which is Postgres pod. In the Postgres pod, we are mentioning a Postgres 12 image with Postgres, and then I'm enabling bunch of extensions and setting the resources, and then in the mount volume, we are setting up the mount path, and in the volumes, we are using the persistent volume claim. See, this is the claim name, Postgres PVC, and Postgres PVC is the persistent volume claim we created here. And the normal thing happens like, so if you want to be exposed, so you need the service as well. So that's it. We have our PVC and then deployment. Let's try to deploy this. I think this is inside the infra folder. Yes, I will first add it. Yeah, you can see it's the same file. There is nothing happening. We don't have to create any folders. You just apply this file. The PVC claim will be created for you, and then the deployment should just happen. Okay, our Postgres deployment was done. Let's check the pods. Okay, our pod is running. The next is let's check the services. Yes, our Postgres service is running, and let's check the provisional volume claims. And our PVC is running with the capacity of 5 GB. Yeah, so how would you access the Postgres container now? We actually didn't set up any ingress route. That means we cannot access the Postgres container from any location. But inside the cluster, we will be able to access. So to access it, we will first deploy a tool called adminer. Adminer is this small PHP application which can connect to any Postgres database. So it doesn't have any storage. It's just like a simple web app, which I use a lot to locally connect to my databases. I'm going to do the same, but deploy it in the MicroK8s cluster, and then we will use the adminer app. Because the app is running inside the cluster, it can access the database. It's just that the apps which are running outside or which are not able to connect. So let's assume that this is a normal web application, and then the application has to connect to the database. We will see how that happens. So this is the container image, adminer, and then the port, and we are using the Let's Encrypt, and then this is the domain which we are going to use. So I think I have the adminer as well here. Yes, it's called pgweb. So you have the file here, and then apply, and then wait for the service to create. Yeah, so ACME resolvers are already there, and then pods. pgweb pod is already running, and I will search for the ingress. pgweb ingress is also running. Let's see if I can go to this application. Yes, I can actually go to this application, and in the Postgres, in the login, you just select Postgres as the system because it's it can connect to multiple databases. So what you have to do is use the server as this. So this is the local DNS for the Postgres we use, we deployed. So the Postgres is the container name, default is the namespace, and svc the local cluster.local is the name of the local your DNS resolver. So you use this as the server, and for the username and password, we can go to the container environment variable, which is Postgres for the username, and then password is my Postgres password, and you can log in. Yes, we are inside our Postgres, which is here, and this is the test table, test database we created, and it's there. We can access. So that means our application is running, our database is running, and our registry is running. All the three stuff I usually need is there. So my usual workflow is I'm a .NET developer. Yeah, I usually create a .NET apps and then deploy them. So that's what I'm gonna do next. So I will create a .NET application, and then try to use Postgres and then deploy it. That will be on the part 4. I hope you will come back and watch. This is the part 4 of the MicroK8s series. In this, we have our MicroK8s cluster available already. So we created everything we needed. This is practically a workflow test. So I will create an application, which is a normal application I would create. It's a ABP application. I have the sample application ready here. I have already deployed it and it works pretty good. So this is a very minimal application. I have made few changes to make it work in a way I wanted, because so I didn't want to run the migration separately, so I'm changed it in a way that the migrations runs every time the app starts. I have marked all those things here. So this is the line I added. So usually there will be a check here in the program.cs. That was okay. I was on the wrong file. In program.cs, you would see that so usually it will be checking for the parameters. Like this, this condition will be checked. I am ignoring that condition, and then every time the application starts, I'm adding the migrations. So this way, I don't have to worry about when to run the migration, since it's a dev machine. I don't care. That's one thing. And then second thing is, I have added the forwarded headers because we are hosting this inside nginx reverse proxy. So while doing that, the protocols will not always be forwarded. So to make sure the protocols are forwarded, I added the forwarded headers. And then I used Thai to deploy and then generate the kubeconfigs and all those things. So as I said, the application is in the repo. If you want, you can follow along. Otherwise, just go and check the application. And then the application also has the kubeconfig, all the Kubernetes things generated for you and then properly configured. You can just skip the video and then play with the repository if you want. But for sake of verifying, let's start from scratch. I will create I don't have a to-do app. I guess, do I? No, I don't have a to-do app, so I think I can create a to-do app here. First thing is just run the command. You need to install the ABP CLI if you don't have it. ABP CLI is from this ABP framework. It's a really cool open source framework. If you don't know about it, go and check it out. It has a commercial version, but also open source version. All the code is available in the GitHub. To get started, just come here and install the CLI, and then you have the ABP CLI with you. So once you have the ABP CLI, just copy this command and then run it. So what I'm saying here is I'm using the no app template and then using the preview version, because right now there is preview 4 of the version 6 running. So I want to use the version 6. That's why I'm using the preview versions. And I'm mentioning my databases as PostgreSQL because we, in the MicroK8s cluster, we have a Postgres database. Just enter, and then this will create a simple .NET application for you. Okay, they have a RC5. Okay. If you want more information, just go and then check out the ABP website. If you want to know what the templates are, or what are the other templates available, you can come and check. I'm using this ABP single layer project type. They support almost all the possibilities you can think of. And the next thing is Thai init. Before that, let's go and then check out. Okay, it's still creating. Okay, it created the project and also run the npm packages to get everything ready for you. And also it seems like create the migrations as well. But let's find out what's in. What we have is a very simple application here. This is what I removed. I removed this this check here, and now the migration will run every time the app launches. Before that, I want to check the app config because I have localhost database. Okay, I want to check if the to-do app database is available with me, and then my password is okay. Just to be safe, I will choose the database as to-do file. Yeah, that is it. Let's go and run the app and then see. Okay, it's migrating the host database. Okay, our application is running and it launched. Let's log in with the default. Yes, everything works. Perfect. Log out. We don't need this anymore because we are just going to host the empty application. The next thing to do is to init the tie. It's really helpful to init the tie and then use the tie to build and then deploy the application. So it makes things easier because if you're a .NET developer and you don't want to deal with creating all these Kubernetes configuration files, it just creates things. It just makes things really easy for you. Yeah, I have done this already. Yeah, but I didn't do this. So first let's do this. So I have to go to the configuration service. This is the configuration service, and then I have to add this. So what I'm saying is yeah, so I'm configuring the forwarded headers, and then I have to come and then say, hey, just use the forwarded headers as well. Okay, we have updated the forwarded headers, and now this is our registry. We have to go and update the tie file because tie creates the stuff for us, and then we have to let the tie know, okay, this is our registry. Now, yeah, I want to update the version so that we can tag the applications properly. So I want to tag it as 101, then see how it's tagged, and now go and build the tie. See, it just tagged it properly based on the version I gave. Yeah, so you can try to push it if you're logged in. So since I've already logged in, all I can do, I can just say type push, and then it will push the push the Docker image automatically to the registry we created. You can see that. Okay, that's the registry we gave to the tie. It's actually pushing the Docker image right now because we are already logged in. Yes. How would you verify this? Like registry is, it says like, okay, I actually pushed. You can go back to the server, and then you can go to mount registry and then put ls, and go to Docker and then registry and then v2, and then you can go to repositories and you'll see the to-do app, and then yeah, everything is there. So we can be sure our to-do app, which we just did here, whatever the pushed here actually worked, and then the files are available in the Docker registry. So this so now we have our Docker container tagged and then pushed to the registry. What can we do now? The next step is to generate the YAML file, because yeah, you can go and create the files. It's not so much, but it's also nice when you have like 5-6 services, and then you can just generate the YAML file just like that. So in that way, tie helps us a lot. So I'm going to output the okay, it says the output cannot be found. I was just click generate. That will generate the file automatically. I think I have to update the blog post. It seems like yeah, so to do generate production, that's the YAML file which was generated. So you can see that the to-do app, yeah, everything is properly configured for us, and then the container and the registry is also configured for us. Yeah, image pull policy always. Yeah, logging, service to-do app, everything is generated for us. In this, we have to add some stuff. So some stuff are like, I have to update the connection string and then update the self URL. That's for the application. And then we have to create the ingress. So this is the ingress I have created. We are using the Let's Say encrypt and the public, and I'm also mentioning the URL rewrite targets and also putting the path prefix here. It's a pretty simple setup, but the only important thing here is that, okay, we mentioned this is the image, right? But the image is protected inside the registry, and so that we have to provide the image pull secret called regcred. If you remember, in part 3 I created this regcred. So if you go to registry, blog post, and then you come here, this is where I'm creating this regcred. So I mentioned that we are mentioning all these things so that the newly created Docker image by us can be easily retrieved. So that's what we are doing here. So we are providing image pull secret, which is regcred. So this will use this regcred and then pull our image for us. So yeah, first I will just think I can get this directly, I guess. Yeah, I can get the YAML directly, so I will do that. Yes, I have the YAML with me to do, and we have all the things ready, but the image is wrong here. I have mentioned as 1.0.4, which is wrong. So let's go and update. On the bottom, this is 101. Update the image and then apply. So we have our application deployed, and then it should be in to-do app kdev.entosbash. Let's see, pod is running and services, to-do services are running. The ingress, the to-do app ingress is also running. So now if I go to this address, yes, I have my app. I have all the images. Can I log in? Yes. Yes. Everything works as expected. So yeah, that's pretty much it. So we have our application running in the Kubernetes cluster. It's a pretty decent dev environment. Let me know what you think in the comments. If you think you can improve it, let me know. And I will see you again in something else. Goodbye.